Okay, so we differentiated trig, and so as the pattern goes, we now integrate, and you basically run through the same thing we've done previously, which is I say integration is the reverse of differentiation, and so given that the derivative of sine is cos, then the integral of cos is sine. And again, given that the derivative of minus cos was sine, the integral of sine is minus cos. And because the derivative of tan was sec squared, then the integral of sec squared is tan. Okay, and that's exactly how it goes. So let's just dive straight in and do some examples. So it says, the curve sine x is sketched below. Well, I didn't copy that bit. So here's sine, something like that. And it says, show that the first arch, now this is what they refer to here, has area 2 square units. Okay, so the area, I'll show this there, so pi sine x dx, and we know that the integral of sine is minus cos, back up there, okay? So that's minus cos x between 0 and pi, and again, what I tend to do is I just write that down and then I just do a quick check in my brain whether it's correct. This is also on the reference sheet if you need it. Okay. Minus cos pi minus cos 0, so that's minus 1 plus 1, so that's 2. Tick. Okay. Evaluate these. All right. Well, integral of cos is just sine. And that's 0 minus 0, which is 0. And that makes sense in terms of an area, because this is the area that they're asking us to do. So it's this, and they are the same. Sec squared, so the derivative of tan is sec squared, so the integral of sec squared is tan. And then, of course, I ask you what is tan pi over 3. So that's pi over 3. So that's root 3 over 1 minus 0, so that's root 3. And then, same again. Oh, this stupid book. Undefined. Okay. The reason it's undefined is because pi over 2 exists in this domain, and that's an asymptote. Okay. I don't know why they keep wanting to do this to you, but I would not anticipate that occurring in an exam. Okay, if you try to evaluate this, you'll get a number. So you get tan 3 pi over 4 minus tan pi over 4. And that's, so tan 3 pi over 4 is in the second quadrant, so it's minus 1, minus positive 1, so that's minus 2. And a bit of a hint that something's gone wrong is you've integrated sec squared, it's a square, so it's always positive, and you got a negative number. Okay, but again, this thing here that the textbook is doing to you is not nice, it's unfair. I would be surprised if that occurs in an assessment. Okay, we should be safe for this question. I'm sorry that I didn't notice that before. So the integral of cos is sine 3x, and again, I just do a quick check in my head and I say, what happens when I differentiate sine? I get positive cos. Now, the thing I didn't do, there's a 3 there. So that means I would have liked to have had a 3 here, so I'll put a third at the front. So I get a third there. Okay, it's the same as the log idea. It's the idea that when I do the chain rule, I'm going to multiply by 3. So I have to counteract that, and I have to divide by 3. Between pi over 6 and 0. So that's sine pi over 2, a third. minus sine 0. So that's a third times 1, or a third. Okay, again, when I integrate this, when I differentiate to get here, I will have multiplied by a quarter. So I put a 4 out the front, and the integral sign is negative cos. So 2 pi on 4, or pi on 2. So cos pi on 2 is 0, and cos pi on 4 is 1 on root 2. And I'll times that by root 2 over root 2. Not that you need to, but I might as well. And I'll get 2 root 2 when I simplify it. And then lastly, so the chain rule here is going to be on the 2x. So I will have multiplied by 2, so I want a half out the front. And so I get a half tan 2x plus pi between 0 and pi over 8. So tan pi over 4 plus pi, so that's 5 pi over 4, minus tan 0 plus pi, so tan pi. So tan 5 pi over 4, so that's in the third quadrant, so it's positive, so it's 1 minus tan pi is 0. So we get a half. Okay, this trick, it's not a trick, this method, right, here, 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 is really crucial. Okay, and I really need you to make sure you understand it, and if you don't, you need to fix that. Okay, and you can ask me for help, quite obviously. Okay, these ones are classics. We always ask you these. So, and there's a trick. So the first thing you do is you rewrite cot. And you rewrite cot as, so tan is sine over cos, so cot is cos over sine. And then you notice that the derivative of the bottom is the thing on the top, right? It's like I was saying with log. It's a fraction. The derivative of the bottom is on the top. So it's a log. And it's the log of the absolute value of sine plus c. Okay, we'll do that again for tan. We should absolutely remember this method, if not necessarily the formula, which is if I ask you for the integration of sine, cot or tan, you should absolutely write it as the fraction version. And now it's a fraction, so I think, is it a log? Well, is the derivative of cos sine? Almost. The derivative of cos is minus sine, so I'll put a minus there, which means I also put a minus out the front. And now it's minus log cos x in absolute values plus c. Next, the derivative of this, find the original, okay? So first thing I'll do is I'll find y. So y is the integral of cos x, and that's sine x plus c. The derivative of sine is positive cos. Okay, it has a y-intercept, in other words, it has a point at 0, 3. So I sub that. Okay, so now they've decided to change their notation, which is really nice of them. So fx is sine x plus 3. So f pi over 2 is sine pi over 2 plus 3 is 4. Right, notice that I'm going pretty fast, I know, and I hope you're pausing and stuff if you need. But we're just doing everything we've done before with normal polynomials, with exponentials and logs. Right, now we're doing it with trig. All the same types of questions, because that's what we need to be able to do. Okay, same again. So there's f dashed. So what's f? Well, f is the integral of sine 2x. Pause it here and try and do this without me. Okay, now I need a 2 there, which means I need a half there. So that's minus cos 2x plus c. You don't need to worry about the minus sign with the c. So that's minus cos 2x all over 2 plus c. So that's f. And then it says f of pi is 1. So 1, sorry. minus cos 2 pi over 2 plus c. So cos of 2 pi is 1. Minus 1/2 plus c. c equals 3 over 2. fx is that. And what does it want? f pi over 4. So f pi over 4 is minus cos pi over 2, which is 0, plus 3 over 2, so it's just 3 over 2. So now we've got to differentiate, hence integrate. So I differentiate, I multiply by 5, I subtract 1 from the power, and then I multiply by the derivative of the thing inside, so that's minus sine x. So that's minus 5 cos to the 4x sine x, hence integrate. And we want the thing we wrote just here in the integral to look exactly like the derivative. So I multiply by minus 5, and then I multiply by minus a fifth at the front. And so that's minus a fifth, and we know it must be cos to the power of 5x plus c, because that's what we differentiated in part A. Homework's there. See you soon.